Today's topic is centripetal force. As I told you already that centripetal acceleration acts towards the center, or the acceleration direction is towards the center. Along the radius, we say along the radius. What is centripetal force? We say the force acting on a body, the force acting on a body towards the center of the circular path. Towards the center of the circular path, keep it in circular motion, to keep it in circular motion is called centripetal force. So in the diagram, body is suppose moving like this, center is here. When the body is here, what direction velocity will act? Velocity direction is like this. What direction the force will act? Like this. When the body comes here, direction of force will be like this, whereas direction of velocity will be by the tangent. Here, velocity is like this, but the force will be acting like this. Here, the velocity will be along the tangent, but the force will be like this. Direction of force and direction of acceleration is the same, along the radius or towards the center. Does force remain uniform or variable? We say it is variable, because direction is changing every time. Whereas magnitude may remain the same, magnitude is same, but the direction is changing. This is in the left side, this is downward, this is on the right side, this is the upward direction. So the direction keeps changing. Such a force is called centripetal force. What direction does it act? Towards the center. Name the force required to keep a body in uniform circular motion. Name the force. The name of the force is centripetal force. What is its direction? We say towards the center. Petal means towards the center. Centri means center, petal means towards. Okay. We have to give some example of centripetal force. Example. Number 1. First example of centripetal force. We like force of gravitation between planets and sun provides the necessary centripetal force. That means force of gravitation will be equal to the centripetal force. Second example, we write here electrostatic force. Electrostatic force of attraction between electrons and protons provides the necessary centripetal force. To keep electrons revolving around the nucleus. Third one, friction. Please write down friction between rod and tires. Friction between the rod and the tires provides provides necessary centripetal force, provides necessary centripetal force for a vehicle, negotiating a term, negotiating a term on a curved track, negotiating a turn on a curved track. Next one you write, tension in the string provides the necessary centripetal force, when a piece of stone is tied, T-I-E-D, is tied to one end of the string, and whirled, W-H-I-R-L-E-D, and whirled about a horizontal circle, Okay. Please try to understand what we have written. We know the example of uniform circular motion is these planets revolving around the sun. What gives the centripetal force for the planets to keep revolving around the sun? We say force of gravitation between the planets and the sun. Your question may come this way: what provides necessary centripetal force to the planets for revolving around the sun? We have to write the answer: force of gravitation. They may give one such case. These are the cases there in your syllabus. They will give one such case. Another one: electrons are revolving around the nucleus continuously. So what gives the necessary centripetal force? That time we say electrostatic force of attraction between the electrons and protons. Electrons are attracted by the center, that is where the proton is there, that is in the nucleus. The proton is attracting the electron, positive attracts the negative. So electrostatic force between the electrons and the protons gives or provides the necessary centripetal force for the electron to keep revolving. Third case we have written, when a vehicle is taking a turn on a curved track, taking a turn on a bent road. So what gives the necessary centripetal force? There we say friction. Friction between the road and the tire will give the necessary centripetal force. That is why it is advised not to have high speed while taking a turn, while negotiating a turn. Because if the speed is high, friction value will be less. So there is a chance of skidding or accident. Fourth case, let us take a piece of stone and tie it to one end of the string, and the string we are revolving like this way, so that the piece of the stone is describing or whirling in a horizontal circle like this way. This way it is going around. So there also the motion is, the piece of stone is having circular motion. What gives the necessary centripetal force? There we say tension in the string provides the necessary centripetal force. So these are the example of centripetal force. Centripetal force formula is there, but formula you don't require now in class 10. So that formula you do in class 12. and I'll just tell you the formula of centripetal force is like this: F is equal to mv squared by r. This is the formula of centripetal force. In this formula, M is mass, F is force, V is velocity, magnitude of velocity, and r is the radius. More the mass, more the centripetal force required, or the value of centripetal force will be large. More the velocity, more the force. Less the radius, more the force. So it depends on these three factors. You have to see it lightly, or don't take it so seriously, this formula, because formula is not there in class 10 syllabus, but I am just giving you the formula for the centripetal force. Okay. The topic centripetal force is covered. Now we are doing the last part of this chapter, which is called centrifugal force. Centrifugal. Centrifugal force. What is centrifugal force? Centrifugal force is the opposite of centripetal force. Centripetal acts towards the center, whereas centrifugal will act away from the center. To describe the equilibrium of the body, we know the body is moving around, the body's motion remains unaffected. That means the body remains balanced there while in motion. How can the body be balanced at one point? We know the fact that equilibrium is possible when the forces, net force acting on the body must be zero. When the forces are balancing, one force is acting like this, then another force must act in the direction opposite to it, like this, opposite to it. Just to describe the motion, or just to describe the equilibrium of the body. This force which acts away from the center of the circular path is called centrifugal force. That means when a body moves in a uniform circular motion, there will be two forces acting on the body. One is centripetal and one is centrifugal force. Which is the real force? Centripetal force is the real force, this force. And this force is an imaginary force, or we call it fictitious force, or we call it a pseudo force. Pseudo, P-S-E-U-D-O, pseudo force. This force actually not to given, but just to describe the motion, or just to describe the equilibrium of the body, such force is taken into consideration. We assume, we imagine that there is a force acting away from the center to keep the body in equilibrium, that is in the motion or the uniform motion. Such a force is called centrifugal force, which is not a real force. It is an imaginary force. It is a fictitious force. So write down the definition of centrifugal force. Please write down. The force acting on a body. The force acting on a body. The force acting on a body directed away from the center, directed away from the center, directed away from the center of the circular path, directed away from the center of the circular path is called the centrifugal force. Is called the centrifugal force. Centrifugal force. This force is an imaginary or fictitious force. This force is an imaginary or a fictitious force, or a fictitious force which is used only to describe the equilibrium of a body in a circular motion, equilibrium of a body in a circular motion. Whereas centripetal force is a real force. Right. Centrifugal force is equal in magnitude. Centrifugal force is equal in magnitude. But opposite in direction. To the centripetal force. Okay. Now another thing. Newton's third law says that every action has equal and opposite reaction. Here also we find centripetal force is towards the center and centrifugal force is away from the center. That means this force, though they are equal in value and opposite in direction, but is it a reaction of the centripetal force? Is centrifugal force a reaction of a centripetal force? The answer is no. Though it is equal in value and opposite in direction, but it is not a reaction. Why? Because action and the reaction both take place. Action reaction always occurs on two different bodies. They never act on the same body. Action and reaction. We have many examples. When we hit the wall hits us back. Action is the force you apply on the wall, and wall is giving a reaction force on your hand. So between two different bodies, we are pushing the ground while walking. So when we push the ground pushes us. Action is the pushing of the ground, and ground giving us a reaction which helps us to walk. So between two different bodies, between ourselves and the ground. So action and reaction is always between two different bodies. Remember, while rowing a boat, we push the water in one direction, the boat moves in the opposite direction. The action is the pushing of the water, and the motion of the boat is the reaction. So between two different bodies always. But do you think that this force and this force are acting on two different bodies? Answer is no. They are acting on the same body. They are only. So this force is not the reaction of the centripetal force. Please write down this one. Although centrifugal force is equal and opposite to the centripetal force, yet it is not the reaction of the centripetal force. Because action and reaction occurs between two different bodies. Whereas centripetal and centrifugal force act on the same body. Yes. So with this information, the theory part of this chapter is finished. Theory part is over. Now we have to do the numericals. Numericals means problems. Numericals formula will be only one formula. You can write moment of force or torque. T, denoted by T. Torque formula will be F into D. Perpendicular distance or just F into D will write. This is the sign of perpendicular. And unit also will be A sign will be Newton meter, and force and distance unit we can multiply. That unit also we can write. Only one formula is there. And clockwise moment direction we will take negative, and anti-clockwise direction we will take positive. Find total moment, so there we will be taking positive sign, negative sign like that. And we will check according to the figure given what direction the rotation will take place or turning effect will take place. It will take place in the clockwise direction or anti-clockwise direction depending upon the figure given. Okay. Now let us take the question number 1. First question I am taking. Suppose they are showing a diagram here like this. First you get some idea, then we will be doing the problems from the book. So here is the point O given. One force is here F1. F1 is given 2 Newton. This is given 1 meter. F2 is here 3 Newton. This distance is given 2 meter. F3 is given 4 Newton and this distance is given 2.5 meter. And question is asking, find the resultant moment of force. Resultant is total. Find the resultant moment of forces about the point O. Find the resultant moment. This is very simple. Answer we are finding now. First we like the resultant moment. Resultant MOF, that is moment of force. We'll do one by one. First force is F1. What is the value of F1? 2 and the distance is how much? From here till the distance is 1 meter. Let us write 2 into 1, 2 into 1 here within bracket. And now we will give a sign, positive sign or negative sign. Can you see in the diagram what direction will it move? Here is the pivoted, so we are giving a force like this. What direction does it go? It is going in one direction, like this direction is what? Clockwise. So clockwise we put a minus sign. Very good. F2, here is the point of pivot, so if something you keep it, above this point it is turning, so the force is down, so this also will give clockwise. So here we have 3 into the distance. From here till the pivoted point, the distance will take the total distance from the pivoted point to the point of the force. 1 meter plus 2 meter, that is 3 meter. Total distance from the point O you have to take. From the pivoted point to the point of force, where the force is acting. And this is also clockwise, we put a minus sign here. We can put within bracket minus sign. And now coming to this one, F3. F3 is 4 into, what is the distance from here to here? What is the distance? 2.5. And what direction will it move? I am sure this will move in anti-clock direction. Here is the pivoted point, force is acting here this side, so if we do like this, put something down here, push it down, this will go like this, that means anti-clock direction. So if it has a positive sign you need not to show, it is already there. Now we are simplifying and finding that this is coming minus 2, this is coming minus 9, 4 into 2.5 is coming 10. This is minus 11 plus 10. The answer is coming minus 1 Newton meter. Unit is Newton multiplied by meters. Yes, I read Newton meter. So answer we can write with the minus sign, and within bracket we will write down minus sign. What does it mean? It means that the body is moving in clockwise. Minus sign is given for clockwise direction. We will be writing it clockwise. When the overall answer comes with the positive sign, we will be writing anti-clockwise. Your answer may come 0. When the answer comes 0, that means the body is in equilibrium. The resultant force with torque, resultant moment of force becoming 0, that means the body remains horizontal, will not turn at all. The body will be in equilibrium in that case. It's quite simple. By chance the answer comes 0, I'm talking about that. Okay, this is one case. This type of question may carry 2 marks. Now the another one we can see. And what we got. Again, question number 2 says, find the moment of force. Find the resultant moment of force. Says, find the resultant moment of forces about the point O, as shown in figure. A figure is given to you and question is asking, find the resultant moment of all the forces about the point. How to find? Let us find the resultant moment of force. So we will do one by one. F1 is 2 into how much is the distance? For F1, the distance from here till O is 1 meter, right? Take 1. What should be the sign of this clockwise and anti-clockwise? Accordingly, we will give the sign. What sign should be given? Because here is the pivotal point. You are keeping force is downward here, so this is going in anti-clockwise direction like this. So positive sign. Plus, I will go to F2 now. F2 is 3. Distance is 1. What direction will it rotate the body? Here is the pivotal point at O, and we are giving a force in the upward direction like this. You can check. It is going in what direction? Anti-clock. Again, so positive sign. I will go to F3 now. F3 is 4. 4 into how much is the distance from here to here? The distance is 1 meter plus 1 meter. That is 2 meter altogether. All the distances you will measure from the point O. Remember. What direction will it rotate? Here is the fulcrum is going this side, that means clockwise, so minus n. Then I will go to F4. F4 is 1 into from here till O, the distance. How much is the distance here? 1 meter plus 1 meter plus 1 meter. 3 meter, that is 1 meter, 1 meter, 1 meter altogether, 3 meter. Please count the distance properly. And what direction it will move this clock? So here is the fulcrum. Keeping something like it go like this way it will go, that is again clockwise direction to minus sign. Now I go to F5. 4 into from here till here the distance 1 meter plus 1 meter, that means 2 meter. What direction this will be turning like this, anti-clock positive side. Now I go to F6, the last one, 2 into how much the distance from here till O? 2 meter plus 1 meter, that is 3 meter. What direction? This is like this, and pushing it up there. This is going in anti-clock direction, that positive sign. Let us work this out. This is coming 2 plus 3 minus 8, minus 3 plus 8 plus 6. We simplify. Minus 8 plus 8 we can cancel. Minus 3 plus 3 also will go 8. 8 Newton meters. Answer is coming with the positive side. We will write the remarks and it's anti-clockwise. Write there anti-clockwise. Anti-clockwise. This type of question can be expected for 2 marks. In compulsory it might come. So for today we are doing this much. Next day we will continue with this. We will do the next 10 problems from the book and all. And